Start.
Hello, we are Team 110. Today's topic of presentation is brain tumor detection using convolution neural network. Brain tumor is one of the hostile diseases in the world. If you talk about US, there are 100,000 of cases pending in the US, and diagnosis has to be very accurate. So generally, the MRI scans that we get, either by the neurosurgeon or radiologist, they have some issues like shadow present in the images. So it can lead up to many problems, like the time consumed by a doctor. So to solve this problem, we came up with a machine learning technique using CNN to detect brain tumor, and if the brain tumor is present, to tell the location in what part of the brain the tumor is present. So our baseline model has the accuracy of 58%, and the baseline model is VGG16. Uh, and the proposed model that we are using is the hybrid model. With VGG16, we are using ResNet 50 and Inception V3. The data set that we got is from Kaggle. So there are around 3,000 to 4,000 images. And there are different types of tumor present, as namely mentioned here, glomia, meningomia, and pituitary. So in the data set, we have different types of images classified mainly these three, and as well as there are images which do not have tumor. These are the sample images present here. As we have mentioned earlier, there are images which do not have tumor, as well as the images which have tumor, like pituitary tumor or glomia tumor. So our baseline model is VGG16. So VGG16 is 16 weighted layer baseline with a 13 CNN layer and 5 max pooling layer. The problem here with the VGG was it was very slow to train, and it requires a lot of bandwidth. So we came up with an approach with a hybrid model which has a ResNet 50 and Inception V3. ResNet 50 has 34 layers and Inception V3 has 43 layers. So the problem which we solved was the data was getting properly trained, and within the bandwidth requirement, our data set was getting trained. Proposed
Coming
model
on,
architecture.
yes. So coming on to the model architecture, we can see that we start with the input data set, which is basically MRI images of these containing the brain tumors and some which do not contain brain tumors. Uh, we go on to the VGG16, Inception, V3, and the ResNet layers. So, describing each one of these layers, what they are basically is VGG16 is a CNN that has basically 16 layers of depth, as Aditya said. These are trained using over a million images on the ImageNet database, which is a pre trained model of the network. And this pre-trained network can categorize photos into like 1,000 objects, so, including several animals, keyboard, mouse, etc., like a lot of objects. So this is one of the best models that we can use for image classification. Coming on to Inception V3, it's a CNN consisting of 48 layers. And so basically, Inception V3 accepts images with a resolution of 299 by 299. Coming on to ResNet 50, it stands for Residual Network, which is a deep CNN architecture. It's 50 layers deep, and the network will accept images with a resolution of 224 by 224. Next, we come to the dropout, which is a regularization technique, which where randomly selected neurons are being ignored due to training to prevent overfitting. uh, when we flatten, basically what we do is we are just flattening the multidimensional output to a 1D array to be used in the next layer, that is the dense layer. The dense layer is a fully connected layer where the neurons connect to all its activation functions from the previous layer, and typically it's computed with a weighted sum of the inputs plus a bias. Again, we use dropout to prevent overfitting just before the final classification. And finally, we are able to classify whether a brain tumor is detected or not.
So these are the baseline model parameters and performance models that we will see in the following slides. This is the tabular data that we have actually referred to before coming up uh, to the hybrid model. Going on to the next slide, this is the parameter table, the tabular data for the proposed model. Next slide, please. So this is the baseline model performance. As you can see that we were able to achieve an accuracy of 58% through our baseline model, as explained by my teammates, which is the VGG16, which is a simple CNN model. Next is the proposed model performance. The hybrid model, which is a combination of VGD16 along with the transfer learning models, that is our ResNet 50 and Inception V3, we were able to achieve an accuracy of about 80%. So based on the comparison between the baseline and the proposed hybrid model performance, there was a notable change and a boost in the model accuracy, that is from 58% to 80%. Moving forward in the future scope, we will focus on increasing that accuracy to more than 80%. That's all from our side. Thank you. कहाँ सेव होता है?
Stop